Welcome to Grade 12 Organic Chemistry. My name is Jeremy Gibbon and I'm going to be your teacher for this section. Organic chemistry is an incredible section of chemistry. I'm hoping it's going to spark your imagination, get you thinking, and really take you into a world that you haven't been into before. Organic molecules are everywhere around us. Our bodies are made up of an incredible mix of organic compounds. The clothes we wear, made up of polymers, probably the most common one is polyester. The fuels that drive our cars, cook our food, generate our electricity, all of those are organic. We can go on and on. Foodstuffs, medicines, pharmaceuticals, paints, you name it, they're organic molecules. I think it's fair to say that whether we realize it or not, organic chemistry is the very chemistry of life. You probably haven't come across a great deal of organic chemistry so far in your studies, but with over 12 million organic compounds, it's clearly a very, very important section of chemistry. The classification of organic chemistry relates to the study of carbon-containing compounds, but excludes the oxides and carbonates and their related compounds. The subject developed towards the end of the 19th century with a growing interest in the chemistry of naturally occurring substances in plants, in animals, and in people. For many years, chemists believed that the compounds in living organisms contain some kind of vital force. It became known as the theory of vitalism. Friedrich Wöhler finally disproved the theory of vitalism when he synthesized urea, a well-known organic compound found in human urine, from the inorganic compounds of lead cyanate and ammonium chloride. But the theory of vitalism hung around for another 20 years or so. So what is it about carbon that makes it so special and gives rise to these millions of organic compounds? We're going to look at 4 specific properties of this element. Carbon's in group 4 on the periodic table, so as you know, makes 4 covalent bonds and tends to bond to itself, to oxygen, to hydrogen, and to nitrogen. Carbon is also kinetically stable, so under normal conditions it's pretty slow to react. It has this amazing ability also to bond to itself, and so we end up getting long chains of carbon, ring structures, and that gives rise to the phenomenon that we see of these millions and millions of compounds. And then finally, carbon compounds exist as isomers. It's the slightly different arrangement of the same atoms in different kinds of compounds, but more about that later. During this module, we're going to learn about the basic families of organic compounds. We call those homologous series. We're going to look at some of the rules around naming organic compounds. Then we're going to shift into physical properties, look at melting point, boiling point, and vapor pressure. And then really interesting stuff, we're going to dive into some organic reactions. Gets a little bit complex there, but we're just going to look at the basic reactions, and then we'll finish off the section by having a look at polymers and in particular plastics. To be successful in this module, you're going to have to learn some of the basics around identifying and naming organic compounds. This is going to take some hard work, but it'll pay off later as you get used to that part of the course. We're also going to spend a lot of time drawing structures. So get some paper out, have a pen handy. Your ability to draw and name organic compounds is going to be crucial to success. I hope you're going to find this a fascinating and enjoyable topic. Organic chemistry is a gateway to an array of fascinating careers, some of them very lucrative indeed. Let's get going.